Welcome back to Bee Spice. In this session, we'll learn about how to design instrument equipment layout in control room, meaning all the panels and other instrument related items, how to design a instrument equipment layout in a control room. So that is the intent of this discussion. Okay, so this is the typical look and feel. As you can see here, this is the layout wherein you can have all these positions. The panels are positioned, right? So you can see the rack room here. This is the technical room and many more. Of course, this is just a sample. We will explain with the help of a we'll discuss rather, yeah, we'll discuss with the example, with the typical example of project document. Okay, right. So now agenda, I'll just touch upon objective. Why we are preparing this layout? What is the objective? Then what are all the contents we should focus on this layout? Then preparatory activity for this design. Preparatory activity like the document requirement, prerequisite, all these. Then the actual design, how to design. Then finally we'll talk about or discuss about the layout with a typical example. Okay. So, objective. Equipment layout shall be used for information about the installation of equipment in control room. This we all know, right? Information about the installation of equipment in control room. Okay. Then second, what else? This layout is used to confirm the arrangement of space as where to install the instrument equipment. Instrument equipment in the sense consoles, system cabinet, like DCS, ESD, FGS, PLC, power distribution, marshalling, and many more. So basically, this layout is to confirm the arrangement of space. Okay, that's it. Check the functionality of equipment upon installation and operability to reserve space for installation for additional equipment in future, right? Once we done all this installation, we should also reserve spare space for future installation. Okay. So this is the main objective and few more to add up. And also see this equipment layout is used for to reflect the equipment installation data into other related layout drawing in control room, such as cable tray layout, wiring layout, all these. You got it, friend? See, this reflect the equipment installation data. See, this installation data should be reflected to other drawing also. That is my viewpoint. Okay. So the equipment layout is used to reflect the equipment installation data into other related layout drawing in control room. Okay, such as layout, wiring layout. Probably I don't know whether you got it. See, what I meant here is, see, once we done with all this installation layout of this drawing, once we complete this equipment layout, okay, so this document we can use as a basis for cable tray. Okay, that is the point, cable tray layout. So in that same document, you should mark up the cable tray. You got it? Okay, good to go. Few more to add on. See, data and information about checking the height, width of the space for carrying each equipment, weight of each equipment, shape and size of the entrance door. All this should be part of this equipment layout. And also we should also use for define the material and the calculation of quantity. How many panels, how many, sensors, like, the fire and gas, all these. Okay. Then information about building group. See, for example, to design the channel based support for the panel and also to access floor, free access floor, and also for HVAC related system. All these we should make use of this actually. So the equipment layout will give all this information. Okay, right. Then information for the electrical group also. See, not only the HVAC team depends on this actually layout. So he also, the electrical group also need this lighting for this lighting fixture or CCTV, mounting and emergency light, paging system, all these. So just imagine the importance of this. So much of informations are there, and many team are depending on this particular equipment layout. So information for firefighting group also. You know the VESDA system, right? Yes. And piping, fire and smoke detector, all these information should be part of this discussion. So that is about the objective. I think it's a clear. Okay, now we'll see what exactly the equipment layout should indicate. Okay, layout and size of the equipment, of course, the complete layout. Of course, when we talk about the example, you will understand more. So layout and size of the equipment, location of instrument inside and around the building. Instrument in the sense, not the field instruments. I'm talking about the fire and gas detector, all these, okay, smoke sensor, all these, okay. Then layout and size of the panel of the equipment which are supplied and installed by other disciplines, say like HVAC, UPS system, PAGA, all these, okay. Then equipment list also shows the data and information of equipment number, equipment tag, description, the size, weight, manufacturer name, everything, right? So these are the contents. See, this all should be part of the equipment layout. Okay. Of course, when we see that, you will get to the real typical example, you will get to know more. And also equipment installed by other discipline. See, we prepare this from instrumentation point of view. There are also equipment to be installed by other discipline that also should be indicated with the corresponding discipline name in the remarks column. Okay, discipline means other discipline. Okay, electrical, like that. Okay, good to go. So then what else? Distance between the equipment and equipment. So panel to panel and between equipment and the wall, I mean the clearance, it's like approximately 1 meter or 900 mm. Okay, taking into account the space availability for accessibility and maintenance. So this is also should part of this. All this information should be indicated in the equipment layout. And location of field entries. Field entries mean the cable coming from field and the cable pit. I will show you that in the diagram also. Cable pit and cable penetration, the entry. So we call it as a MCT, right? A multi cable transit, right? Yes. So that is also should be indicated. And of course, the interconnecting cable, all these. Then sectional details of complicated installation. So if anything you want to explode and detail out. So you need to have the sectional detail. For example, in the tray layer, okay, not tray actually, maybe in the panel, you want to have the sectional detail, then that section should be indicated accordingly. Okay, that's it. Then legend showing the details of equipment such as symbols for equipment, future equipment and side panel. Legends also, the current equipment and the spare space for the future equipment, maybe probably with a cloud mark, and the side panel. All these should be part of this. And notes, notes should be there, and key plan mark, the key plan mark, you understand, right? Key plan mark and all these scale bar, everything should be part of this equipment layout. Okay, and of course the work demarcation with other discipline, whatever we do. Okay, but if anything is to be handled by other discipline, that should also be part of this. Okay, then now we are done with the contents basically. Contents, what is supposed to be. Now, for preparing the design, what are the prerequisites or what are the documentation we need? Okay. So basically, friends, let us building drawing of the control room. That is important. See, building drawing of the control room in the sense, the layout, the size of the pillars in the control room, other instrumented related room, layout and size of the door, window, cable pit, all should be in that drawing actually. So where we will get this? This one we should get it from the building group. Okay, as a base drawing, the base drawing for us to update. Okay. Then the latest vendor drawing and documentation indicating the dimension, weight, channel base, installation procedure with respect to the equipment. This should be obtained from the MAC, meaning the main automation contractor, system vendor. Okay. So that they will give all the panel drawings, including dimension, weight, everything. In fact, we have already seen all these, how to design a cabinet, system cabinet, everything. So that part is separate already. So this is the layout. Okay. Okay, good. Then latest information. HVAC system, UPS, all these also we should gather. Okay. Then project specification also we should get it. Instrument installation. Is there any specific standard for instrument installation, right? Criteria. So that also should be there. Okay. Now, few more. Standard typical drawings. See, during a project, we prepared a standard typical drawing. So that also should be referred. Then equipment number and information defined by system vendor. Yokogawa, somewhere, Emerson, like that. Then equipment arrangement based on the system vendor. So they will arrange some sequence, right? Like a DCS system in one, row. Then we have a emergency system in other row, and we have FGS in other row. So they could have organize, I mean, arranged some layout kind of the basic arrangement. So that also should be referred. Then project specification for instrument installation and layout. I think this is getting repeated. Never mind. Okay. So these are the preparation for the design. Okay. So now we go into the actual design. See, here listed are the steps, friends. What we have to do. First, of course, we have to obtain all the design details as we discussed in the previous section, right? Okay. Under design preparation, right? Okay. Now, so we have to define the drawing size. What is the size and scale? Okay. If you are using CAD, otherwise you can use also SPA. Now, most of the people are using SPA. And drawing size, preferably A0 or maybe A3, depend on the requirement, preferably A0. Then drawing scale, 1 is to 100, but if it is too congested mean, then we can go with 1 is to 50. Okay. Then obtain the latest CAD or SPI drawing from the building group, as I highlighted earlier. So we need to get the base drawing from them. So these are the design steps to start with. Then few more. Now insert the design contents of the equipment layout. So we have the equipment layout, right? Like from the system vendor. So that one we need to insert here in this layout. See, basically how we have to do it. First, plot the equipment based on the initial equipment arrangement concept prepared by the system vendor. Okay. And of course, coordinated by the system engineer with the customer or end user. Okay. You have to plot that into this drawing. Okay. So assign the equipment number based on the equipment list prepared. See, there should be some sequence, right? 01 up to 02, 03, like that in a sequential number, right? I will also show that when we discuss about the panel layout. Then consider space for transporting and maneuvering the equipment during installation. So there should be sufficient space for shifting all these. Then also consider space for operability, maintainability, and accessibility. See, approximately 900 mm. If you have sufficient space, you can go for 1 meter also. Coordinate the channel-based support details with the building row. So that is also important. Okay. See, for example, you are mounting on a channel, right? So the channel will be sometimes embedded into the control room, right? So those things we should talk about with the civil team. Building group means civil. I'm talking about civil. Okay, right. Then confirm the sufficient space to allow for maintenance to be conducted while the doors of the equipment are fully open. When the doors are fully open, we should have a sufficient space actually. Okay. And consider equipment height and arrangement with regard to the HVAC, lighting fixtures, ITV, all these should be focused on this when you do the design. Then consider the installation of equipment and instrument related to ESD. See, ESD is very critical, right? That should not be clubbed with the DCS process one. It should be mounted, arranged in a separately and preferably near to the, door, what do you call it? Immediate for easy access to reach of the operator. Okay. And sufficient space around each equipment in the control room. That also should be there. And arrange position of equipment in control room for protection of the operator console, any reflection of external sunlight. This is just an option. If you have a challenge in getting, the reflection of light, so you have to position that in such a way that the light will not get reflected. Okay, that's it. Yes. Because the light reflection will cause, hindrance to the operation and viewability. That's the point. Okay. So then arrange a layout of equipment by considering prevention of interference with any appliances fixed to the wall of the control room. That is also important. See, you would have some PDB wall mounted, or maybe the fire and gas we mount on the wall, right? So that should be, somebody should not see, for example, when they open the door and when they come and, do some work in the panel on the way, if this is, is a hindrance, then it should be taken care. We should not install in that way. We have to, try to keep this all in one place, maybe at the end of the, the wall. Okay, right. So that's my view actually. Consider dimensional information on building drawings, such as wall or column, center, all these we have to take note. Consider equipment installation sequence for larger equipment. Say like larger equipment should be first, then the smaller one, like that. Okay. Then equipment layout around HVAC, exhaust duct route, FNG, all these also should be taken note. Okay. Then information about the location for installation of electrical equipment, such as fire and gas system, wireless communication facility, all this we have to get it from the electrical group and reflected in the equipment layout. Okay, right. So these are the design and few more to add on. Information about the location of the location for installation of building equipment such as HVAC. So that also should be obtained. HVAC system, any panel, HVAC panel, right? So those things also should be reflected. Get it from our civil team and reflected. Building group and reflected. Then dimensional data, basically equipment dimension, panel height, depth, width, all this. Then distance of equipment from the center of wall or column. Then elevation of wall mounted equipment. Elevation of the wall mounted equipment. How much? See, for example, it should be in operable range, right? Like we are having, like 1 meter, 1.2 meter, that is easily accessible. That's what I meant. And depth of the free access floor or cable pit. So that also we should indicate actually. I will show you all this. Then detail and location of size of the MCT. This is called a multi-cable transit. So that also, of course, this will be prepared in a separate drawing. If you are interested, you can comment. I will also take about this subject. But the point what I am saying here is this MCT references to be indicated here in the layout. I will show you in the layout. Okay, later. Okay. So that again. And okay, now almost we have done everything. So what I want to say here, at this point, the resulting equipment layout, whatever we have, right? So that can be used as a base drawing for layout of instrument cable tray and in the control room. That's what. So you don't have to, prepare a separate, drawing for this. So in the same equipment layout, you can do this instrument cable tray. That's what I meant. Okay. Of course, if you are interested also, I'm willing to take a, separate video on this and upload a video, but you let me know. Okay. And collect and compile the data information of each equipment to complete the equipment list that will be inserted into the drawing. Meaning there should be some tabulation kind of thing, which I will show you in the drawing, like, panel number, panel name, all these, the location, the vendor, all these should be there in a form of a tabulation form. And additionally, specify the following information. Title block, of course, you know this. Drawing title, drawing number, file name, scale, job number, project title, project name, logo, and what do you call it? The name of the designer, all these, revision number, description of revision, reference drawing, all this should be part of this drawing. Okay, that's it. So then title block, yeah, few more actually, same thing actually, it's getting repeated. Yeah. So this is the layout typical example. I will take you through the typical example. So allow me to toggle the screen. Yeah. So I will show you here. Where is this? Yes, I think this is the one, right? Yes. So this is the one. Hope you can see these drawings. Now I'll just blow a bit of it. Yeah, you can see here. This is what I was telling, the direction, right? Okay, you can see here the direction. Okay, yes. So that one you need to plot it. Yeah, of course, that will be there in the drawing itself, the original drawing. Then you have this, layout. This is where you can see here. Maybe I'll go through one by one. Yeah. You see here, friends, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, all these are the panels actually. I will show you here the table. You can see here, this is the equipment list. This is what I meant. We need to get this from the equipment vendor, right? Vendor. You see here, one. equipment number one. This is my tag. This is the DCS cabinet. So how many you need? Two numbers. So what is the width? All these. Then what is the weight? All these. Okay. Likewise, you can group it. So the DCS is grouped here, right? So the DCS all grouped here. Okay. Of course, this is based on the grouping we received from the vendor. Okay. Then after that, 13 finished, right? Then we have to proceed with the, what do you call? Yeah, the next one, 15. Yeah. Yeah, 15. So this is a marshalling. So system cabinet we are done. Now we have to see the marshalling. Marshalling started from 15. So system cabinet all grouped here. So we are done with that. Then we have to see the marshalling. Where is that? One moment. Let me see here. Marshalling is not indicated here. Yeah, probably the marshalling will be in the other drawing, I think. Never mind. So the intent is this is how we need to include. This is how we need to include. Okay, maybe we'll see marshalling is missing here. Then probably the other page, I think. What I have is only one page, probably in other page. Okay, no worries. Then we have this, after this marshalling, we have the power distribution cabinet. Yeah, we have a power distribution cabinet, the dimension, the earthing cabinet, and patch panel, fiber optic cabinet, then IPS. This is what I mentioned. This is the ESD system from 31 to 37. Then we have IPS marshalling cabinet, then HIP system, FNG system, all these. So based on the tabulation, this is one of the item we received from the system vendor. So these things we need to plot it here. That is what I meant earlier. Okay. You can see here, all these are plotted here. You can see here, right? All these from 39, 40, 49, all these up to 51. So basically, if you look at that, yeah, so now I think it is there. I think we missed out. See, now it's a DCS, right? Up to 15, it's a DCS. Not 15. I think one moment. Yes. So 13, up to 13, it is DCS, right? Yes. Up to 13, it is DCS. Then you are from 15 onwards. You can see here this guy 15, 16, 17, 18, 19, 20, 21. These all marshalling cabinet. You got it, friends? Yes, that is how. So if you can see here, the system cabinet are here. So marshalling cabinet is routed here. You know why? Why it is mounted strategically, see, these are the cables coming, you see the field cable entries all coming from here, right? So that is why it is easy actually. The multi-core cable coming here, right? Yes, that is how it position like this. Okay. So that's about the panel basically. And of course, you can see here other panels, right, from 22, 23, 24, 26, all these up to 29. As you can see here, this one. This is the fiber optic, patch panel, all these. Then after that, IPS 31. Let's see, where is this 31? Where is this 31? I think 31, 37 is there. Where is 31? 37, 36, yeah, probably here. Yeah, you can see here 31, 32, 33, 34, 35, 36. Yes. So this is, this side actually. Basically, it is, you can see here, this is totally grouped in one side. As you can see here, all DCS related. Here, as you can see, all IPS related. Okay. So that is the thing. Okay, friends. Right. And also you can see the entry also here. So the door entry, everything is one side. And additionally, what else we can see? And you can see the HVAC room. So this is also there. Currently, only one panel is there. One HVAC system 104 is there. And you also UPS battery 103. That is also there. Then you can see the door access here, door access here. This is a separate room, rather it's a separate room. So our panels are in different room actually. Okay. Then we have the very important thing, as you can see here, this MCT. So multi-cable transit. Yeah, this is the one. So when the field cable comes, all this, so it has to come through the multi-cable transit. So this is the field entry, field cable entry, and this is the cable pit. This is the cable pit. This also you should show. Okay. Right. Same way, this side also we have a cable entry. So here you have a cable pit and the MCT all should be there. Okay, right. So why I put here, right? Refer MCT arrangement details. So this will be a separate drawing. Okay, right. The point is we should put this reference here. That is the point here, right? So that's about this. Then yes, and this side also, as you can see here, cable entries, right? Yes. So this also there, cable fit is there. So this is how we should mark, friends, taking into account all those whatever we have discussed earlier, all the points. So now I'll just show you here. So this is the complete equipment system, DCS, sorry, I think, yeah, DCS, marshalling, power distribution, IPS marshalling, HIPS, FGS, all these should be part of this. Okay. Now, few more to add on. This is basically equipment list building work. Building work means, the terminal board, HVAC control panel, all this. It's a separate equipment, not from our main, DCS or ESD. Okay. Then additionally, you have this instrument list in instrument technical room. So this is what, basically you see here, friends, 111, 112, like that, up to 125, right? So I will go here. You see here, this is the instrument technical room. Okay. Here you can see here, all these are mounted like this. Okay. So if you see here, the first 111 is IPS engineering station. This is FGS annunciator, IPS annunciator. Likewise, you need to mount a right one. Okay, this is at the instrument technical room. So probably we call it as a engineering. Okay, with all these engineering stations. So this is how we need to plot and come out with the equipment layout. Okay, hope it was useful. Okay, thanks for watching. And what else? Yeah, that's it. That's it, friends. And yeah. That's it, I think. Yes. Yeah. Thank you. Thank you. And if anything, you can write to me. Yeah. Thank you. Bye-bye.